Greetings, everyone, and welcome to adding intelligence to your Cosmos DB applications with Java. Actually, let me start that again because I screwed up the title. Greetings, everyone. Welcome to adding intelligence to your Java applications with Cosmos DB. My name is Brian Benz. I'm a cloud advocate at Microsoft, specializing in Java. So I'm excited to be here and sharing this with you. So we're going to talk a little bit about the evolution of applications. I'm not going to spend a lot of time on my slides. We're going to dive right into a demo, which is going to be most of the presentation. So originally we had on-prem applications. Everyone has their own stories and struggles with those. You had to manage applications, you had to manage servers, you had to manage infrastructure, you had to make sure security was on top of things. Whether or not you had them on-prem or in a co-location or in virtual machines, all of that still had to be managed for you. Then we moved into the cloud. The cloud came along. You've got virtual machines. They're great. They solve the physical problems that you had with working with your applications. But you still had other problems. How do you actually manage those virtual machines now? How do you actually manage those servers? Is my cloud secure? Can I scale using the information that I have? All right. And then what is next we moved into platform as a service or software as a service. And, we had issues like what are the right sizes of the servers for our business? Are we paying too much for the services that we have? A very common problem. In fact, there's a whole bunch of folks out there who've generated an industry on saving people money on their software as a service and platform as a service cloud infrastructure. So it didn't solve all the problems that you had. And then, of course, serverless came along to help solve all the problems we had with on-prem, virtual machines, platform as a service, software as a service, by allowing you to abstract away all the infrastructure that you need for building your application, for scaling it, and for managing security. So now we've got serverless out there. And this is a way to actually help you build your application. And this is what this presentation is all about. You can take your code that you already have for Java on-prem, and you can enhance it greatly using services that are in the cloud, including serverless. So we're going to talk about the platform components that you can use to do what I just described, which is basically taking your code and enhancing it without changing the underlying infrastructure and the underlying code. Azure Functions are the main part of that. So Azure Functions are our serverless platform at Microsoft. They're complemented by Logic Apps. So Logic Apps are a way to organize your workflow and organize your application structure, also to integrate with the outside world. So functions are very simple. They just take a request, they return a response. Logic Apps are a way to coordinate and orchestrate those functions and other things, including connections to third-party platforms, Twitter, things like that. In the demo I'm going to show today, the functions are actually integrating with a simulated IoT infrastructure, which generates temperature data and shares it with your applications. Event Grid sits adjacent to Logic Apps and Functions. And Event Grid is a way to manage all of the calls and responses that go into your functions and other things. So functions scale all by themselves. You can take a function, you can run it, that call and response architecture runs great and it scales well. But then there are the requests that work with the function. So if you're getting 1 million IoT requests every second, and they need to be processed by a function or anything else, Event Grid is a way to do that. So there's a queue in there that allows you to scale your activity that integrates between the different applications. Underneath that, we've got databases like CosmosDB. We've got storage, and of course, security is very important. You can integrate with IoT. Today, the demo I'm going to show is simulating that. You've also got some really good analytics, and you can build in what we call intelligence, which is artificial intelligence, or just application intelligence, which is being able to use functions in an event grid and logic apps to build out some smart applications without on the same old dumb code that you've been working with for a long time. On top of that, for developers, we've got IDE support with your favorite IDEs or Visual Studio Code, which could be your favorite IDE. I didn't mean to say it wouldn't be, or Visual Studio. You've also got integrated DevOps using GitHub Actions and Azure Pipelines. You can use all of those for local development and management as well, and deployment. We've got monitoring, and then you've got debug history using Azure Monitor or other tools as well. So they all integrate really nicely and really well because they're all built in the same platform with the same developers in mind. So a little bit more about functions. What exactly are functions? Functions are code and events combined. Basically, it's a way to trigger something that connects to something else. And that's what we call triggers and bindings. So in this case, a new record comes into Cosmos DB, or it comes into Event Hub, and it's going to trigger an activity. In the case of the demo I'm going to show you, we have temperature data coming into an Event Hub, and that Event Hub triggers Cosmos DB. Event Hub triggers a read into Cosmos DB. You've also got queues, service bus, and other things. And the bindings themselves are whatever the activity that the trigger has created. So let's say a new record comes into Cosmos DB. You want to trigger a new record comes into the Event Hub. Actually, you want to trigger an entry into Cosmos DB. That's what your binding is, that entry into Cosmos DB, for an example. All right, so that's enough of the actual overview here, and I'm going to dive right into the demos now. So the demo that we're going to use today can be found two different ways. There's a tutorial out there, and we'll share the link at the end. And this is just showing you step-by-step how to create a function in Java with an Event Hub trigger and a Cosmos DB output binding. So remember I said triggers and bindings. There you go. Event Hub trigger, Cosmos DB output binding. And we're going to use the Azure CLI for this, and you can use Bash or Windows command for that. I'm not actually going to build it. I've got one pre-built, but the other thing that's kind of cool is this has already been, the code that we're working with has actually already been pre-built in this repo. So there's a repo called Azure Samples Java Functions Event Hub Cosmos DB, which actually has most of the structure and the code already built into it. Or if you want to build the whole thing from scratch, you can use this tutorial as well. Okay, so what does this actually do? I'm going to start at the end. Here is the Cosmos DB database. And as you can see, it's kind of big here. I've got to just make this a little smaller so we can see the temperature data. All right, so the temperature data itself is a record, is a JSON record. And this data is generated by an Azure function. The Azure function itself, I'll show you the one in the GitHub repo, is really simple. Here it is. And the Azure function doesn't connect to IoT, but it simulates IoT. So this is where you would actually connect and get a dozen or a million temperature sensors sending you data. This kind of replicates that. It's sending about 60 requests a minute to our Event Hub, and then the Event Hub processes it and sends it to Cosmos DB. The code itself is dead simple. It's just meant to be a demo to show you how to connect everything together. So it's not meant to be fancy, but it basically just uses a random number to generate some temperature and pressure data that gets passed into the Event Hub. So let's start in the tutorial. And I'm just going to go through. You do need to have at least Java 8. You need Apache Maven, and you need something called Azure Functions core tools and their instructions on how to set that up. If you click on that link, it can run on Windows, Mac, or Linux. And you can use Bash or Windows command for the tutorial. Like I say, I already pre-built this because it takes several minutes to generate each one of the items I'm going to show you today. And it was just easier to pre-build it and then show you how it works. All right, so the first thing we do is we set up a bunch of environment variables, and I already set these up. And then the next thing we do is create a resource group. And the resource group itself, let me show you the Azure portal. This is a good way to illustrate the resource group itself. So the resource group is how you actually organize all your resources together. In this case, we've got a Cosmos DB database, Cosmos DB function app, event hub, a storage account, and an app service plan. The app service plan actually manages the scale for the function app. And all of those are organized in this resource called Cosmos DB Conf 2022-0419. By the way, this is the Azure dashboard inside my portal. If you go to portal.azure.com, if you don't have an account already, you can set up a free trial, but it allows you to sort of interact with things like this. And you can organize your portal into dashboards. So I've got a dashboard for Cosmos DB Conf and other events, but you can organize your dashboards any way you like. So that's what we're looking at here. And I've got a couple other applications down here that I'll highlight as we go through. So back to the tutorial, we created a resource group. Then we create a event hub. You create a namespace for the event hub, which is like a main account for the event hub. And then you create the actual event hub that's going to do something. And then you have an authorization rule. The authorization rule tells this event hub what you're going to do with the event hub. In this case, listen and send are the rights that you're giving to this application. You're going to listen for something coming in from the Azure function, and you're going to send data to the Cosmos DB database. And that's how that works. All right, next thing we do, here we are at Cosmos DB Conf. Let's create a Cosmos DB database. You create an account. Once again, you create a sort of a storage area for all of your databases, which is called an account in Cosmos DB using the AZ Cosmos DB create. It's a Azure CLI command. And then you create a SQL database. The SQL database is called telemetry DB. And then the SQL container inside that database is called telemetry info. So we go back and we look at our Cosmos DB application. It's telemetry DB is the database. The account is Cosmos DB Conf 2022-0419. Telemetry DB is the database, and inside there's a container for telemetry info. And inside that container, I'll zoom out again, is the actual records. So you can see the records here as they come in. They're just JSON records. All right, so back to that tutorial. Next thing you do is you create the storage account and a function app. So the storage account itself contains the function app. The function app itself, if you notice, the runtime is Java, and the functions version is 2. There's several functions you can use. This is one of the older and more basic ones that works with Java 8 and beyond. So that's all you have to do is run that command, and you create an actual function. So we've got the Azure Cosmos DB now. That's this one here. We've got the Event Hub, which is here. Let me zoom in a little bit more on that. And I'm going to show you the different events and things that are happening there. And then we've got the function, which is here. And all of those are here in this Azure portal resource group. So they're all organized here. The app service plan we need for that. But now we need to connect all these together. So if we go back to the tutorial, the next thing we do is retrieve some resource connection strings. You want to create a storage account connection string because that's actually what manages the connection for the function. And then you want to create an event hub connection string that manages the connection to the event hub. And then Cosmos DB connection string, which connects the event hub into the Cosmos DB. So Basically, Azure Web Jobs storage is the connection string that's going to connect our function to our event hub. The event hub is then going to listen for activity from the function, and it's going to pass data to the Cosmos DB database using this connection string. So the connection strings are automatically generated by each one of these resources, and they are secure. They're extremely long tokens that you use to connect between these applications securely and reliably. The next thing we do is we use the Azure CLI using that AZ function app command. And what that does is it adds all of those connection strings to the configuration of the function. And then there's inside this tutorial, it goes on to show you how to build a local version of this and test it locally. But I did it the lazy way. I went out to the repo that I mentioned before, and I just took their code, which actually did all that already. So it's organized everything into the right place. And the only thing I had to do was add those that memory to the connection string. As long as I was in the right place in my GitHub repo when I ran that, it would actually add those connection strings into my function automatically for me. All right, and the next thing I did, let's flip over. So we're flipping over to the GitHub repo now, and the only thing we had to do after that was run Maven clean package. I mentioned Maven as a prerequisite. That's the build manager for Java, and then you say Maven Azure Functions run. That runs it locally and allows you to test it out. You can check the monitor the logs to make sure it's running. But then the easiest thing to do is just run this command, which is Maven. Let me zoom in a little. Maven Azure Functions deploy. And what that does is it actually creates a function out on the function resource that you've already created back in the early steps in that tutorial. So it deploys it automatically out there. And once you've got it deployed, then the function is actually automatically running, and you can go into Cosmos DB and I'll check this again. And then you just refresh this and the data rolls in automatically. And if we check out the overview of Cosmos DB, you'll see the application, and it's taking a minute to load. Yeah, there we go. So the application itself has been running since yesterday. I set it up. It was kind of dead until then. I set it up beforehand. So you can see the activity coming into the application. It even gives you the cost for this. So far, it's cost me 42 cents to manage this data in Cosmos DB. The next thing it does, we can check out some more telemetry. If we look at the actual function app, so this is the function app that generates the simulated temperature data for you. And it tells you how much memory it's using, the execution count. In this case, there was no need to scale, so it's basically managing the same scale all the time. But this basically connects to your function. The function calls your event hub. So that's what we're looking at here. The event hub itself runs, and you can see here we've got 2,400 requests since last night when I created this. And basically it connects to the Cosmos DB conf database, and that's what I showed you earlier with the JSON data that's coming in. So basically it shows you in here built-in monitoring, built-in tracking, and you can see for some reason it's kind of fallen off recently, and it's not really running as much as it used to, but it ran pretty consistently for a while and generated that data. So just a recap here, the Cosmos DB itself was fed by the event hub, and the event hub was fed by the function, and all that is contained inside this resource group here. And that's basically how you would do that. So the idea here is we took this Java application that does a really simple thing, and we didn't have to change the code. We added an event grid for scaling. We added a function for scaling, and we added a Cosmos DB database to store data. Of course, with Cosmos DB, you might have heard by now at Cosmos DB Conf, is really good for replicating and managing that data geographically, for making sure that it merges all the data. So you could theoretically, for example, create an event hub that distributes this data to different versions of Cosmos DB all over the place, and or replicates them into a central database. So it does all that for you without changing your Java code. That's still the plain old Java code that we had before. Now, I mentioned before logic, so logic apps. I didn't talk about those. So this is a standalone application that generates its own data, but if you wanted to connect to something else, you would use logic apps. And I'll share this link after, but the standard tier connectors, as you can see, there's 1 or 2 standard tier connectors here that you can use for your application. For example, Twilio, Twitter, Trello, hey, Typeform, haven't seen that for a while, WordPress, all kinds of things that you can connect together with your application and feed your Azure functions or your event grids with triggers and data and connect that way. So the idea here is logic apps you can orchestrate and connect with, and then the functions run. They use event grid for scaling of actual activity that's feeding the function, and then Cosmos DB stores the data. Now, I do have a link I want to share with you. Function triggers is here, aka.ms/function triggers. You can get more information there, and we'll also have some links associated with this video, and I'll share a copy of the presentation as well. But you can recreate this demo using the links and the tutorial and the repo. My name is Brian Benz. I'm a cloud advocate at Microsoft, and that was adding intelligence to your Java applications with Cosmos DB. Thanks for joining. I hope it was useful.